Welcome, everybody. I hope you can see and hear me well. So welcome in the afternoon session of our second event on the promoting space sustainability, awareness raising and capacity building related to the LTS guidelines project. Today, we are focusing on space agency operators, and we asked each speaker to showcase what space sustainability and the long-term sustainability guidelines look like in practice through their work. As a reminder, I just want to ask from everybody to please turn off your camera and your microphone so we can enhance the quality of this virtual event. Thank you. Just a little bit of an overview from our morning session. When we could hear from space agency representatives from the United Arab Emirates, Romania, Thailand, and the European Space Agency, they all covered space sustainability from their own operational experiences, and also they elaborated how their everyday activities are mapped across the relevant LTS guidelines. Also, as we are recording both sessions, we will make the video recordings available on our website at unusa.org, as well as on our YouTube channel. And we will also upload the slides that are being used today from each of the presenters, along with the operational case study reports, which is kind of a summary report of what is said today in a written format. Also, just again, please keep your camera off and your microphone off. And in case, also, if you have any question, just please use the chat function of this MS Teams program. You don't have to wait until the end of this session, because even we encourage the presenters to engage in this chat and answer to some of the questions during this whole event. So without any further ado, I'm giving the floor to my colleague Ian Freeman, who will moderate this session further on. Thank you very much for tuning in and enjoy this promising event. Thank you.
Hey. Thanks, Annie, and welcome to everybody for this afternoon's session. As Annie said, we did a nice tour of the global space sector this morning with some European speakers and some speakers in time zones to the east. And it's now the turn in this afternoon to look more to those Western time zones. So we've got 4 more great speakers for you lined up today. The first joining us from NASA, and then we will be moving, staying in that hemisphere, moving down a little bit to Chile, and then jumping over the Atlantic to the UK before going down to the southern hemisphere with colleagues from SANSA, the South African National Space Agency. As with this morning, we're going to be inviting each of the speakers to be delivering presentations on the case study which they're bringing to today's session. So 10-15 minutes from each of the 4 speakers, and then, as Annie said, we'll be moving into a Q&A session where we'll be posing questions to the speakers. But do please feel free to use the chat function as we go, and I also ask the speakers to keep an eye on the chat function during the entire session to see if any questions are coming in their direction. Okay, so that's it from me. So I would, with absolute pleasure, hand over to the first speaker for this afternoon's session, who is Miss Laurie K. Newman, Conjunction Assessment Manager at NASA. So Laurie, please, the floor is yours. Over to you.
Hello, everyone. Thanks very much. Let me share my screen here real quick, maybe. All
It's a
right,
great
well, maybe not.
background you've got there. No problem.
Thank you. Yeah, Teams tends to be helpful and want to show you 55 recent files instead of the one you want, so it's buried down there somewhere. But it was just a background screen, so I just won't share it. Or if you're, if you have the backup copy and you want to share it. Oh,
Yeah,
thank
we
you.
do. There we go. Thanks, Annie.
Okay,
Off we go.
see, you haven't missed anything. Thanks very much to the United Nations Office for Outer Space Affairs for inviting me to participate in the event today. I've been working at NASA for more than 30 years and currently serve as the manager for the NASA Conjunction Assessment Risk Analysis Program, which has been my role for the agency since the program's inception 16 years ago. The increasing utilization of space, including a significant increase in the volume and diversity of commercial activity, means actors need to take responsibility for maintaining outer space as a stable, safe, and sustainable environment. It is in the interest of all nations to ensure a stable and orderly space environment that drives opportunity, creates prosperity, and ensures our security on Earth and in the vast expanse of space. In this regard, NASA is thrilled that COPU has adopted the preamble and 21 guidelines for the long-term sustainability of outer space activities, as they represent best practices for the safe and responsible use of space. These voluntary guidelines mark an important milestone in ensuring that all nations can continue to benefit from the use of space for future generations. To that end, LTS Guideline B4 recommends performing conjunction assessment during all orbital phases of controlled flight. In accordance with that guideline, NASA performs conjunction assessment for all operational missions during their entire mission lifetime. And my CARA program is responsible for performing conjunction assessment for the non-human spaceflight missions, so we support about 70 spacecraft. Since Explorer 1 was launched on January 31st, 1958, the United States has reaped the benefits of space exploration. New markets and technologies have spurred the economy and changed lives in many ways across the national security, civil, and commercial sectors. Space technologies and space-based capabilities now provide global communications, navigation and timing, weather forecasting, and more. Space exploration also presents challenges that impact not only the US, but also the international community. A significant increase in the volume and diversity of activity in space means that it's becoming increasingly congested. Emerging commercial ventures such as satellite servicing, in-space manufacturing, and tourism, as well as new technologies enabling small satellites and large constellations of satellites, present serious challenges for safety and responsibility using space in a stable and sustainable manner. To meet these challenges, the U.S. seeks to improve global awareness of activity in space by publicly sharing flight safety-related information and by coordinating its own on-orbit activity in a safer, more responsible manner. We seek to bolster stability and reduce current and future operational on-orbit risks so that space is sustained for future generations. To this end, new and better space situational awareness capabilities are needed to keep pace with the increased congestion, and the U.S. seeks to create a dynamic environment that encourages and rewards commercial providers who improve these capabilities. In December 2020, we published the NASA Spacecraft Conjunction Assessment and Collision Avoidance Best Practices Handbook, document safety standards and best practices that consider maneuverability, tracking, reliability, and disposal. The handbook, which will be updated as new CA and on-orbit operations are developed, also encourages the use of commercially available SSA data and information, and for large constellations, it encourages mitigating light pollution to ground-based astronomy. Entities offering or intending to offer SSA or CA services should consider the information in this handbook from the perspective of augmenting or improving upon existing capabilities, as the entire space industry benefits from advancing these capabilities. In the near term, raw observation data can be used to improve close-up approach predictions. Longer-term improvements might be found in enhancing notifications and data sharing, developing new models, and enabling increased automation. NASA continuously examines and actively updates its best practices for CA as the industry undergoes rapid evolution. Large constellations of satellites, for example, comprise a new and evolving paradigm for which NASA is developing in-house expertise. NASA seeks input from the space community to improve the content presented in this document. NASA has a long history of experience with CA and was involved in developing the process that many entities use today. The NASA CA process comprises 3 phases. The first is focused on CA screenings to identify close approaches between a protected asset called the primary satellite and any other space objects called secondaries from the vantage point of the primary. Predicted close approach event information is then sent back to NASA, where our team analyzes the data to determine the risk posed by the close approach. Next, CA risk assessment examines each of those close approaches produced by the screening activity to determine which may represent dangerous situations and therefore require a mitigation action. We found that this risk assessment step is critically important to the CA process. Conjunction data messages, or CDMs, simply provide data, but the risk analysis of those messages allows us to determine whether the event requires action. The third phase, CA mitigation, constructs the mitigation action, usually a trajectory change for the primary object, that will both reduce the collision risk of the close approach to an acceptable level and not create any fresh high-risk collision event. A mitigation action may also involve the sharing of ephemeris data with the operator of the other spacecraft involved in the close approach so that they can perform an avoidance maneuver themselves. Before any of these three activities, screening, risk assessment, and mitigation, can take place, certain satellite data and position information needs to be produced and made available to the CA enterprise. In November 2020, NASA expanded its requirements documentation to provide more detailed, lower-level CA requirements for its mission to help them adopt some of the unique challenges posed by the evolving space environment. This NASA interim directive, NID 7120.132, also expands the agency's required CA activities beyond just those performed after the spacecraft is launched to include previously optional pre-launch activities. In keeping with LTS Guideline B5, develop practical approaches for pre-launch conjunction assessment. Required pre-launch activities include taking steps to avoid co-location of spacecraft to the extent practical, planning for robust communications and data sharing between co-located spacecraft when co-location is unavoidable, and analyzing planned mission trajectories to determine the anticipated number of potential conjunctions, both during ascent and those expected to be regularly encountered in the final mission orbit, in order to estimate fuel usage and expected personnel activity levels. As mentioned previously, the NASA CA Best Practices Handbook accompanies the NID to provide a more in-depth reference to NASA users. However, the handbook is also intended for use beyond NASA. It provides descriptions of methods, rationale for choosing one method over another, and supporting analyses drawn from NASA's long history of performing CA. NASA will continue to invest in research and development efforts to advance the state of the art as the space environment and CA needs continue to evolve. And Annie, if you could please switch the slide for me. I have a slide showing the links to this NASA documentation and the repository, thank you, of publicly available CA software that we've produced that anyone can download if they're interested. So I'll leave that up here for a minute while I finish up. So again, I just wanted to say thank you. Indeed, for more than 6 decades, COPUS has focused on building consensus to advance the peaceful exploration and use of outer space for the benefit of all humanity. And given the scientific and commercial imperatives, we have no doubt that UNUSA and COPUS will continue to make significant progress in promoting international space cooperation. NASA looks forward to continuing to work through this unique cooperative forum to promote space exploration and to reap the scientific benefits from such exploration to improve the quality of life for all here on Earth. Thank you for your attention, and I look forward to our discussion and any questions later on.
And thank you very much, Laurie, for that fascinating overview. A couple of points that I would love to come back to you during the question and answer session. I was very interested in that point where you assessed the automated production of the data, with then the need for that human involvement to come in on the analysis. Any more information about where that interface is exactly between those two parts of the process and where that interface may move with, I don't know, the onset of artificial intelligence running some of the analytics or things like that? That'll be really interesting. And thank you for raising guideline B5 as well with the pre-launch notifications. And then obviously something like that would be heavily reliant on a good communication link between the public and the private sectors in terms of space activities. So it would be lovely to hear a little bit more about how that works in practice over in the US. So thanks again, and looking forward to coming back to you in a little while. Okay, great. So now we're going to be moving on to our second speaker. So we'll be going down south a little bit with Miss Francisca Para Rojas, who is an officer with the Air Force of Chile, and she will be giving us some insights from the Chilean perspective on how space sustainability looks like there. So please, Ms. Para Rojas, the floor is over to you.
Good afternoon, Ian. Good afternoon, everyone. Good morning here in Chile. Wait a minute, I want to share my presentation. Thank you again for the opportunity. And the presentation we have prepared is aimed to tell you about the National Space Program, or SNSAT. And this is a program currently in development, which is led by the Chilean Air Force, as a way to consolidate the national capabilities in this area. Sustainability has been considered as a mandatory concept for all the project phases, and that's why the presentation is called Contribution of the National Satellite System to the LTS Guideline. The outline starts first with an introduction in order to show the main motivation of this project, and then I'm going to describe briefly what is the concept of the project and the 4 subsystems included in this program. And then we choose 4 main LTAs in order to evidence the relationship of the project with these LTAs, and finally a conclusion. Chile has reached a technological base and institutional stability aimed to develop the spatial activity in the country in a more autonomous way. In this sense, this project is based in 3 fundamental bases. In addition to the satellite system oriented to replace the current national satellite, SAT, this program considers all the fundamental pillars. One of them is the spatial institutionality. This program considers to promote and encourage the development of talent, technology, and industry as their capacity for achieving a sustainable use of the space. On the other side, we have the National Space Center, which is oriented to provide a national assembly, integration, and testing satellite capability for public use, which involves not only infrastructure, but also technical resource and human capital formation. One of the goals of this program is to achieve autonomy and sovereignty in space operations. The intention is to acquire the methodology involved in all the space project phases, since the satellites and payloads integration to its launching. It will demand technical formation and also the integration of new capabilities in productive areas, even in defense applications. This involves different services for public disposition, especially associated to data exploitation and positioning system. The strategy for achieving the purpose of the national satellite system is based in 4 frames: technology, financial, normative, and institutional frame. For this reason, the creation of the national spatial institutionality has been so relevant in order to give a structure to support the national space growing. And in this sense, the main areas to be aboard are, in first place, the geospatial information management, which involves not only the information to be acquired with the new satellites, but also the data collected with all the other systems associated to remote perception currently available in the country. Additionally, the products generated by this data will be useful for academic and research projects, benefits for productive sector, and also to collaborate with the global space scenario. Chile has generated local capacities associated to remote perception, activity that currently is led by 2 organizations administered by Chilean Air Force. The Special Operation Group, dedicated especially to the current satellite exploitation, and the Aerophotogrammetric Service. These organisms concentrate and exploit different information that will be complemented with the capabilities to be achieved with SNSAT. Regarding space diffusion, we have to say or mention the International Air and Space Fair has become a great opportunity for joining the main organizations and companies associated to the aerospace field. In the latest years, the sustainability has been an important issue to be discussed in the different meetings that take place in this fair. with the participation of important organisms that lead these topics. The National Satellite System has been segmented in 4 subsystems aiming to support different capabilities to be achieved. The first one is the Geospatial Information Management, and this service is oriented to satellite imagery, collection and reception, not only for optical, but also for radar images. Its purpose is to strengthen the storage, processing, and distribution capability of geospatial information. This subsystem considers a geoportal development, a mobile application to facilitate access to geospatial information, open and freely to anyone. The subsystem 2, oriented to the national technology production, we have to say that one of the main SNSAT project purpose is to increment the national autonomy for spatial technology development, and this subsystem mainly involves an assembly, integration, and testing laboratory for local development of micro and nano satellites and payloads. In this sense, we have to say that Ministry of Science considers as an axis of mission the space weather monitoring for environmental conservation, so the payloads to be included in satellites will allow a permanent monitoring of this topic. According to Subsystem 3, the national satellite, it is especially oriented to replace the current Earth observation satellites HASAT-Charlie, which is currently in orbit. And finally, the Subsystem 4 is oriented to the telecommunications service, which is oriented to support all the satellites communications, obviously, and the ground satellite stations necessary for its exploitations. We choose 4 main guidelines that we have to highlight in its relationship with the project. The first one is the A1 and A2, and to this regarding, we have to say that Chile's foreign policy has been characterized by its decisively addressing exciting global challenges, developing an active participation in the world agenda for sustainable development. Regarding space, Chile has had a permanent participation in the Committee on the Peaceful Uses of Outer Space, not only in the technical, but also in the legal subcommittee. These systems evidence the interest to include the global recommendations in the national space affairs. In addition to current regulation, the National Satellite System program has demanded planification of new regulation about the space development. And that's one of the reasons why the spatial institutionality has been so important for this project. The second one we have chosen is the guideline 8.5. And we have to say that this guideline has been adopted through a ministerial decree a few years ago, which establishes the registry of the space object launches in orbit, on Earth, or beyond it. For SNSAT, it becomes a mandatory practice to be incorporated, which also considers the registration and monitoring of space debris at atmospheric entry. The Ministry of Science is also making progress in regulating the space operation of mega constellation and control access of ground stations to be located within national territory. About guideline B.3, we have to say that one of the purpose of the subsystem 1 about the geospatial information management is to strengthen the capacity of the storage, processing, and distribution of geospatial information. It also will be useful for space monitoring through a geoportal in order to facilitate access for users in different areas of national development, as well as to form a unified space database. In this sense, we can mention the project that is called All Sky, which is currently in development as a collaborative research integrated the Chilean Air Force, the Air Force of Scientific Research, AFOSAR, and the Colorado Center for Astrodynamic Research. And the objective of this project is to evaluate the facility to detect and classify near objects in the city of Punta Arenas in the south of Chile. In this sense, one of the main challenges of this project is the data collection and distribution for remote zones. So this situation will be addressed by SNSAT program. Subfinally, about guideline B.6, about sharing operational space weather and data forecast, we have to say that Subsystem 2 contemplates the local payloads integrations and to different purposes. which includes space weather monitoring and forecast. Data collected by these sensors will be stored in a data lake as a national good for public use in order to concentrate the data available for academic research, productive purpose, defense applications, among others. Additionally, the project contemplates the implementation of environmental ground stations and a smaller substation will be installed in different points of interest in order to complement the information obtained through onboard payloads used in the monitoring of space weather. Finally, as we have seen, several LTS guidelines have been considered as a key part of this project, and the main conclusion that we can say is obviously SNSAT programs aims to develop technology and generate geospatial information about autonomy and sovereignty management of the state. Also, sustainability has been considered since the beginning of the project as a key component according to the government guidelines. The SNSAT program also considers a national and foreign collaboration to complement efforts and optimize spatial resource and capability. And finally, obviously, new aerospace capability will generate public value, social profitability, and economic growing for the country. Thank you very much.
And thank you to you as well, Ms. Parra-Rosas, for that really interesting, fantastic overview of what's happening in Chile through your work, and congratulations for all of the progress that you've made. I was particularly interested in, well, both A5, which is this journey on registration, which obviously recognizes the importance of information sharing, both at the UN level with the Secretary General through the Registration Convention, and then also with your colleagues across the global space community. So it's fantastic. There's a high level of importance being paid for that. So thank you very much for that. And also I would love to hear a little bit more when we come back to the Q&A on that very last point, actually, where you referenced the public value and then also the economic value as well, because these issues aren't captured so much in the text of the LTS guidelines themselves, but it's that sustainability in general, so the social sustainability of space activities and the economic sustainability of space activities, they're very important factors as well. So it would be nice to hear a little bit more about how that works in Chile when we come back in the Q&A session. So thank you again for those remarks, and looking forward to speaking to you again. Thank you. Okay, great. Now we move on to our third speaker for today's session. So hopping back here to Europe, so in the afternoon, Mr. Jacob Geer, who is head of space surveillance and tracking at the UK Space Agency. So Mr. Geer, the floor is yours. It's my pleasure to hand over to you, our next speaker.
Thank you very much, Ian, and good afternoon and good morning to all my colleagues. I will try and share my screen and my slides now.
Perfect.
Thank you, Ian. So forgive me, I cannot easily see you at the same time as talking, so I will speak and then we can take questions at the end. My name is Jacob Geer. I'm the head of the UK Space Agency's Space Surveillance and Tracking, or SST, capability. I know in other nations we talk about space situational awareness, or SSA, or with my military colleagues, like from Chile just now, space domain awareness, perhaps is a terminology used. But I will talk today around the efforts we make in the UK to track and mitigate those, and then also touch on some wider interventions we make to support research and development in the area of space sustainability. We'll be touching on two different aspects of the UK's efforts. The first, my core area, around developing space surveillance and tracking capability at a national level, support the guidelines B2, B3, and before. So particularly the operational focus of the guidelines to actually share data, to understand space debris and orbital information, and then to use conjunction assessment to help avoid any potential collisions. And then we will focus on our investments with the European Space Agency and at a national level in research and development to support other guidelines. So a particular focus on space weather, as I will touch upon later. This is an area the UK has a strong academic as well as operational interest in. And then the wider work we do with the European Space Agency and ourselves to develop new ways to support the sustainable use of outer space, to understand or manage the space debris issue in the longer term. So these are projects which are focused on developing new technologies or modelling capabilities. I won't talk upon our efforts to inform or share information more widely across developing nations. So as part of the section C of the guidelines, we do a lot of work here to share information with other nations. I will touch upon that slightly, but I wanted to flag that this project now, the reason we are all here today, is the UK's keen support to the need to bring other nations together to implement the long-term sustainability guidelines. So although I will not report to those, I think it is helpful to refer to them. In that spirit, I will just quickly, excuse me, Ian, when I try and do this while we speak at the same time. In the chat for this meeting, I will drop some links, which I will touch upon shortly. These links are regarding two research reports which we make freely available. So they are published on the UK government website, and anyone on this call, anyone can access these reports to inform their own understanding, their analysis of space debris and space sustainability. We ask that you reference the authors in the UK Space Agency if you use them in publications or in your internal documentation, but you are welcome by all means to look at that and look in more detail at some of the things I'm discussing. I will move on. So, the space surveillance challenge as a whole, and I think maybe for this audience, a lot of people are aware of the challenge we face. There are lots of graphics and now some good videos from companies and from ESA explaining the risk of space debris, explaining the number of new satellites reaching space. Here is one of the diagrams that I find quite useful to demonstrate to members of the public about why space sustainability and space debris is an issue that needs space surveillance and tracking to resolve. You can see here the different levels of low Earth orbit. I'm just looking at low Earth orbit rather than geostationary or medium Earth orbit here, and the planned constellations that are going up there. So this ignores the current population of single satellites that focuses more on the new constellations at various different altitudes. And then it compares that to where we know there are already some debris fields. And I have tried to list some of these there. They're not necessarily the biggest debris fields or the most worrying, but they are things that we regularly see as we track and monitor conjunctions in space. This isn't a comprehensive view of all the debris in space. It is just a representation to show people that new constellations go to a very busy part of the sky. So some bits of orbit, particularly I think 500 to 700 kilometers, and then maybe out around 1,000 to 1,200 kilometers. There are lots of constellations that want to go there, and when they get there, they will be avoiding debris and other satellites. And so to support that, to make that feasible, operational, and sustainable where we can. We, like many others, many other nations, look to provide space surveillance and tracking capability to support those operations. In the UK, the Space Operations Centre has been set up and established by our military in 2008. My agency then started working together with them in 2016. So having our analysts, as I say, who wear hoodies and t-shirts, sitting alongside those analysts wearing camouflage and uniforms to work together on space surveillance and tracking since 2016. And we have a network of sensors and analysts that work together that use different software, so both nationally constructed software systems, as well as those we can buy commercially, to examine the potential conjunctions. And like the NASA presenter before me, Laurie, we start with the US CDM message. So we take that data that our colleagues and allies in the US are kind enough to provide, and then we use that as the start point for our analysis and do further work to really drill into the risk of different events. And we do this as a nation. It is important to do for our own reasons, to protect our satellites in space and to make sure we operate within the guidelines. But we work closely with many other people. I have called out 3 of our collaborations here in the slide. So firstly, although I am now a little out of date, we helped to co-found or start the EU's Space Surveillance and Tracking Consortium in 2015. Before we left the EU at the end of 2020, that was our key operational collaboration to conduct space surveillance and tracking. But now, of course, we are in a different situation as an independent nation, and so we're keen to continue to work with the EU, but also work with others to collaborate and share our SST requirement. We have embeds or liaison posts working alongside the US in the Combined Space Operations Centre. It is really vital to us, particularly at the military angle, but also the civil angle as well, that we work closely with our allies and partners. And the US, on all aspects of space domain awareness, is a real crucial partner for us, and we enjoy a strong working relationship with them. And we collaborate actively, particularly with COTUS, but also with the Interagency Debris Committee, to inform modelling of space surveillance and tracking requirements, of the debris, changes in the debris population, to understand the long-term risks to space operations, and all of that pulls upon the capability that we use to, in real time, consider and advise on orbital collisions. And now, as we have been progressing through the last 2 years and now moving forwards, we have, alongside the military, considered our National Space Operations Centre, so further deepening that collaboration between the civilian agencies who are interested in hazards or accidents, and the military agencies who are interested in threats, but all need to look at space together to make sure it's sustainable and safe and secure. In the UK, I think one of our key points is how closely we do work together and share capability and share our understanding. And that National Space Operations Centre is a really strong next step. My next slide goes into a bit more detail on some of the activity we are doing. So on the sensors, the data processing and the analysis, 3 key parts of any nation's space surveillance and tracking capability. I have listed some of our more recent activity and also things we are doing to look forward. On the sensors, for example, and I will come on to this shortly, we are awarding R&D grants to our industry to look at low-cost sensors. These might be things that can be deployed around the world in different nations. For example, optical systems work okay in the UK, but we have a lot of cloud coverage. So maybe there is a way we can work with partners there. We are working hard to maintain and utilise our current UK sensors. So upgrading, for example, our tracking radar, which has been in operation for around 40 years. So making sure that it's fit for the 21st century, and then sharing data with academic partners. As an agency, it's important that we make sure our innovators, our researchers have access to the same data that we see. And so we share a lot of our data wider, not just within the UK. I know, for example, we share our data with the University of Austin in Texas. So Marie Vajar's team to enable them to do open source cataloguing of space objects. And that's important to make sure that we can share information widely. On data processing, we are developing national software. It is important to us to be able to monitor our own events with a protected and secure source code. So we do that alongside the mod. And we also are trying to look at new ways of using artificial intelligence, machine learning, for example, to both support the cataloguing of space surveillance and tracking data, but also to try and infer from that collisions, new ways of optimizing missions, for example, which perhaps are need less of a man in the loop and are more automated. And finally, a lot of our resource this year is focused on building the expertise within our people. So our analysts, our orbital analysts. I know some are on this call now. So they are the most important part of the system. We can have all the radars and telescopes and software and algorithms available. But unless we have a person who can pull out the signal from the noise, it is not always useful. So we're working hard to make sure that those people have the right skills and are well trained and have the right interests as well. This is interesting work, protecting the orbital environment to continue. And all of this, which we do nationally, is underpinned by our investment in ESA. So the Space Safety Programme, which I'll shortly come on to, really gives us throughout the sensors, the data processing, the analysis strands of our work, and the pipeline of future activity and understanding that we can pull through. I'll go on to talk about that now. Ian will tell me off for being over time shortly, but I will continue until you tell me otherwise, Ian.
Keep going.
Thank you. So for our investment in ESA, national R&D, which meets the long-term sustainability guidelines related to research and development, but also space weather, so B6 and B7 of the guidelines, our investment in the ESA Space Safety Programme is crucial. The UK, I am proud to say, is the biggest contributor to this programme. We think it is important to work on these activities together, and so that is why we've invested just shy of 100 million euros over a 2 to 3 year period on these activities. So you can see here some numbers to show you where the investment lies. A lot of the interest here is about that pipeline of activity, so understanding new R&D projects and demonstrator missions, but there are operational angles as well. The space weather mission, so Lagrange L5 mission, which we currently have 70 million euros invested in, will help us both to demonstrate new technology, to do new research and development, but also provide a more operational sensor to warn of potential space weather events. And those events can harm all nations across the world. We need to protect ourselves as a nation, but we recognise that space weather is a global issue. And that is why the Lagrange mission is important to us, and I think to everyone as well. It will also help, the ESA Space Safety Program will also help to demonstrate new types of missions or technologies or systems. So the ADRIOS mission, for example, looking at in-orbit servicing. I think there is an automated collision risk mission, CREAM, which is one of our longer-term projects to look at. All of this through ESA gives us future technologies that we can then pull forward when we need them, and we will need them to mitigate the debris threat in space and ensure we have sustainable activity. By doing the underpinning work now, the UK is enabling ourselves, giving us the chance to have those technologies ready when we need them. Underpinning all of this is, I sometimes say to my analysts, the less sexy work. So cataloguing, research studies of orbital population, debris detection in terms of maybe pulling out images, pulling from images, debris tracks, for example. This is not quite the sort of thing that my Prime Minister and my Minister like to talk about, but it is crucially important. And that is why when we look at the ESA Space Safety Programme, we invest heavily in those areas too. I've spoken about our ESA involvement. Let me speak briefly about our national R&D. We have several different strands of research and development. So we have innovation programs, we have space science programs. I'm going to focus here on space surveillance and tracking program. You can see here a few words and a map of the UK. And this program is all about supporting industry to develop new capabilities. So either sensors, low-cost sensors, or new ways of processing data that are perhaps closer to market than the academic or research community. So things that perhaps we can use in the next 2 to 3 years and actually bring forward and buy from a commercial provider. Because industry has a key interest in space sustainability too, with a national interest, but industry need to both operate in space in the future and also, of course, potentially supply new products or capabilities or services. So the map you can see of the UK is with the blue stars is where those companies who applied are located. And the map you can see with the red stars are where some of their international partners were. So a view of the various different companies coming forward to us to say they wish to consider developing a new product or service to support space surveillance and tracking. And on the right-hand side, you can see some of the press we got on this. You can see an article on our BBC website talking about this. You can also see a tweet from what was our minister, our Secretary of State at the time, talking about this development. Now, I put this here to show the importance of this to the UK, but also to reflect to you, my colleagues, actually growing the public awareness of space debris, of space sustainability, is a key part of what I see my job as, and I think what we all do naturally. And having our minister tweet about this to the public, he also wrote, well, I helped him to write a editorial in a newspaper about space debris, about why it was important and why we have invested. That reaches a whole new audience outside of people like you and I who perhaps talk about space more regularly. And that has been a vital thing to do for us in the UK, and also I think is a vital reason we are talking today, and is something we can all do together. So I am, although it was a small piece of work, actually reaching that new audience and telling them about space sustainability and starting to talk around the long-term sustainability guidelines and why they are important to our everyday life, I think is a vital thing for all of us. I think that is my last slide. I have some hidden slides that I can go on to in a minute, but I think my time is up. And I think, Ian, questions will come at the end. So over to you. Thank you.
Thank you, Jacob. Really appreciate that, and thanks for posting in the chat some useful links. I'm sure colleagues are already picking up on those. And we'll have some questions for you in the Q&A session. Just a couple of comments from my side. I really appreciated you focusing on both Section B of the guidelines, space safety operations, and then also Section D. It would be really interesting to hear a little bit more about on the Section B element. So this is all about increasing accuracy of your space situational awareness operations and getting that data as accurate as possible. How that process looks like in practice from the UK point of view would be great. And then obviously Section B3 is all about that sharing and engaging with the scientific community, which also links to Section D of the whole guidelines. And you did mention that there is lots of sharing of data that is going on, not just in the UK, but also in countries elsewhere. I mean, how that looks in practice in terms of and how that operates on a day-to-day level, and how interested parties could potentially do an approach in that regard would be really welcome as well. So thank you so much for those comments, and just a reminder that and all of the other excellent presentations will be made available on the website for people to download and read at their leisure after the event. So with that, I'm going to now turn to our final speaker for this afternoon's session. So we're going to jump down to the southern hemisphere to Mr. Val Musami, who is the CEO of SANSA, the South African National Space Agency. So Mr. Musami, please, the floor is yours. Over to you, sir.
Thank you, Ian, and thanks for the invitation. I'm assuming you can see my presentation.
Spot on.
Perfect. Okay, thank you. I'm just going to very quickly highlight two key programs that are kind of what I consider relevant for the LTS, but I'm only going to speak about one this afternoon. So the one on the right is our ground segment. So at the moment, we're gearing up towards about 70 different antennas from XSC right up to KA and KU band. And essentially what we're doing there, so it's a 24/7 operation, and we provide telemetry tracking and command services for the satellite passes, bringing back the data. We also do launch support. So every time there's a launch from the US or from Europe out of French Guiana, we do the launch support as it comes over Africa. And that's the separation phases, the ejection of the satellite or the payload out of the upper stages. We do the in-orbit testing of these satellites at times and pass it on to the end client. We do orbital corrections from LEO right up to GEO. So there's a lot of work we do around, the orbit maintenance around this ground segment. And that station was set up in the 1960s, and it's still operational and growing. And in fact, we'll be setting up a second ground segment in South Africa because this is getting crowded at the moment. The one on your left is essentially what I wanted to focus on is our Space Weather Operational Center. And this center was established, not the space weather, but the magnetic observatory itself in the 1940s, essentially. And so that's still in existence, but it's grown in terms of the research focus and the domain. And at the moment, it's the only internationally accredited space weather center in Africa. So specific to this conversation, I just want to focus on one of the guidelines, which relates to Space Weather Center. And that's guideline B7, essentially, which is around your space weather models and tools. And I just want to remind ourselves very quickly what guideline B7 entails so that you get a context of where this conversation is heading. So first of all, we're trying to integrate space weather information into looking at the thresholds and how that integrates into the launch criteria as you launch. And then also mitigate anomalies for on-orbit operations. And we're all aware of the adverse effects of space weather sort of events on spacecraft. Also, there's a push for collection, collation, and sharing of space weather information for these kind of operations. And there's also a requirement in terms of common formatting for reporting information, so that when we're sharing this information, that we make sense of what we're sharing in that space. So the the common data standards is going to be very key. And then also there's a need for policies on sharing of space weather information. And then we also encourage to train and provide knowledge transfers. And I think there's a specific reference to developing countries or emerging space nations as well. So that's in a quick nutshell, the guideline B7. But I want to come back to how SANSA kind of relates to this aspect. So we've been part of the working group on the long-term sustainability of outer space activities. And I think colleagues might know that Dr. Peter Martinez, a South African colleague of ours, was chairing this working group that developed the guidelines, which is what we're talking about today. We're also part of the UN COPIOS expert group on space weather, and we're contributing from a technical point of view. And as I indicated, we also have the Regional Space Weather Center. We're hosting that at the moment inside of the agency, which is for the African region. And we also the designated provider state for regional space weather information to the aviation sector. So I think it was about 2 years ago, the International Civil Aviation Organization has passed a regulations where you actually need space weather information in the aviation sector. And I'll touch on that just now. So as I indicated, we have a space weather center inside of SANSA, and we're looking at the interaction of the sun with the Earth's magnetosphere and how coronal mass ejections and those kind of events actually affect us here on Earth in terms of the technologies, including satellites as well. So in 2010, we essentially launched our initial Space Weather Center. That was December 2010. And we relaunched it and revamped it and upgraded it. And so in April 2018, we relaunched the Space Weather Center, and that's our minister with us. And what's interesting, in fact, in 2 weeks' time, we will be doing a sod turning event with our current minister for a completely new Space Weather Center. So this is a totally brand new building that we're putting in, and that's in response to the CAIO designation that we received as a regional space weather center for Africa for the aviation sector. So this is kind of growing from 2010, 2018, and now looking into this financial year, where we're looking at construction starting on site in April. And maybe just to give you a bit of insight, the key focus here is on the aviation sector, but we also do a lot of capacity development from university students. We support about 50 odd masters and PhD students every year. And what's interesting is we are now bringing in a research chair in solar physics from abroad, because this is one of the domains that we thought we needed to beef up our capacity because we don't have the expertise in the country or in-house for that matter. And so that research chair will be starting in April as well, actually next month from now. And that's obviously to build the capacity around our Space Weather Center, which is going to be 24/7 operation. But just to give you a context in terms of why this is important for the aviation sector. So with regards to the new regulations from ICAO, before if a flight takes off, the pilot has to have space weather information on board. And that needs to come from a space weather center, like what we will be hosting in SANSA. And there are 4 different effects that you see on the aviation or on the aircraft. Your high frequency radio communications during these events, you have HF blackout, where there's no communications to the ground segment. Also, you'll see now with the new aircrafts, there's a Wi-Fi on board, and that's essentially talking to your satellite, communication satellite. And there again, you could have some blackout. But I think the big effects is on C&D, which is your GNSS, your navigation and surveillance. And there again, you'll see a blackout in the signal transmission from space into the cockpit. And then we also have increased radiation exposure at flight levels. Now, some of these effects are also out there in space. So when you're looking at satellites, it becomes very important to understand what's happening in space so you can take these mitigation measures even at the space level, not just on the aviation part. So we run, we've got a whole suite of data and infrastructure that supports the Space Weather Center. And so we're looking at measuring space from the ground. We have a base in Antarctica as the only African country that does that. And 80% of our shore-based equipment is space physics related. Okay. And so on your right-hand side, you'll see an antenna array, an HF radar antenna array. So that's part of what is called the Super Dual Auroral Radar Network. And this particular one that's hosted by South Africa intersects with the Halley base, or the UK British Antarctic Survey radar. And so they converge over the same piece of the polar cap. And what they're trying to do is to measure the ionospheric convection in the polar ionosphere and see how the effects of the sun is driving that convection. So you're looking at your substorm events or activities like your auroral events and so on. And so we're trying to understand the interaction of the solar wind with the Earth's magnetosphere. And so this infrastructure is very key in the polar regions. And then we also have a network of ground instrumentation in Southern Africa, ionosondes, magnetic field measurement stations. And then we also own two islands, Gough Island and Marion Island, and they have scientific bases as well. So we have instrumentation on those islands. So you can see a whole network of instrumentation on the ground that's trying to understand what's happening out in space. And I should also mention, because we're right next door to the South Atlantic anomaly, which is very key for satellite operators, because a lot of the events or the adverse events that affect satellites tend to happen over the South Atlantic anomaly between Southern Africa and South America. And that's because your Earth's magnetic field is very weak in that region, and the penetration of the radiation is quite deep towards the Earth's surface. So it affects satellites quite greatly in that area, especially when there's active events. So we're trying to understand all of this and make sense of this from ground, and also using some of the satellites from our partners like NASA and the European Space Agency as part of the Space Weather Initiative. And so where we're heading at the moment with this new, facility that's coming online, as I said, we're measuring space from ground, and we also operate a number of geophysical instrumentation. But what we've started to do in prepping ourselves for the new Space Weather Center, the 24/7 operations, is started to develop a number of products and services. So I'll just give you one example at the bottom end. And this is more for the aviation sector, but we're trying to see how we position this in terms of the LTS as well. So as I indicated, we have just to round up the narrative in terms of where I started, in terms of guideline B7. So we're looking at all of these. So if you look at the top two, we're trying to figure out how to integrate our space capabilities into our ground segment in terms of launch support, in-orbit testing, orbital corrections, and so on. And we also, right now, we're looking at a space situational awareness facility co-located with our ground segment. So all of that will kind of neatly mesh together in terms of providing us some insight and responding to guideline B7, not at a country level, but a global perspective. Because these space weather centers are all linked up. So I think there's 3 global space weather centers and 2 regional, and South Africa is one of the regional space weather centers. And then at the bottom, because we're part of that global network, we also in conversation with the CAIO and WMO in terms of the collection, collation, and sharing of that information. We're also working on common formatting or reporting for that information. But as I indicated, we're looking at that from the aviation sector. But obviously, you can lift that up for space operators as well. And then we also, for the aviation sector, we're looking at policies on sharing of information and already working on encouraging and training and knowledge transfer, because we also have to train the pilots in terms of making sense of how to use space weather information now that it is a regulatory requirement. What I've tried to show in this presentation, Ian, was how we're trying to position capability that we've started, but also expanding into a 24/7 operations and seeing how that can be the part of the mainstream in terms of informing guideline B7. Thank you, Ian.
And thank you, sir. That was fantastic. So many questions from my side, and so perhaps we should pick up the phone at some point and chat more extensively without so many people in the room. I mean, first of all, B7 exactly. I mean, it's that common formatting element that you picked up on. That would be really interesting to know a little bit more about, because obviously it's that, I mean, standardization is probably too strong of a word, but at least, you know, recognizing the multi-stakeholders, the lots of different people involved, the different entities involved, getting those standards or that commonality is so crucial. So hearing a little bit more about SANSA's journey there at some point in the Q&A would be lovely. And then also the role that you're playing in both your region and then globally just demands that relationship again in B7, which talks about between satellite operators and space weather data providers, and how that relationship plays out, obviously in both the national context, the continental context, and then beyond. So a little bit more about that would be lovely. So thank you so much. Okay, right. So I'm now going to move into the Q&A for all four speakers. I'm looking in the chat, and Laurie, I think we're actually going to go straight back to you. We've had one comment in the chat, which was a little bit about, and again, you know, please feel free to answer to whatever extent you want. It's that relationship between NASA, the Department of Defense, and the Department of Commerce in terms of both space traffic management and space sustainability, which may not have been quite as neatly defined from a policy point of view. And then obviously we know that national policies are changing all the time. So, you know, there's anything you can say in that regard would be fantastic. So I give the floor back to you, please.
Okay, thanks, sure. So definitely there's a very close relationship between all of our organizations, DoD and Department of Commerce and NASA. NASA relies heavily on Department of Defense, particularly the 18th Space Control Squadron, who maintains the catalog of space objects. We send our ephemeris data to them and they do the screenings on their end. So we're relying on receiving that data to make our whole process work. And then Department of Commerce is, of course, now starting up developing a space traffic management type architecture. So we've been in conversations with them for several years, offering whatever lessons learned and expertise we have that may be helpful to them and what they're trying to put together. NASA's not a regulatory agency, so you know, we're about the technical information, but we're certainly partnering up with both those agencies to assist with whatever they need in their endeavors.
Thank you so much. And if I could just shift gears a little bit as well, just going back to the case study that you presented. Obviously, you're focusing on assessment, which very much starts with a data gathering process, but at some point ends up with a human-made decision. And just a little bit of kind of granularity, if you wouldn't mind, about where that point changes from the kind of automated part of the process into the human process. You talked about training and getting the staff trained to make those assessments. A little bit more about that would be great. And also, do you think that relationship can shift going forward? So thanks a lot.
Sure. So we do use an automated system to receive the data that we get from DoD and process it, and we produce a report that goes out to our users that helps them monitor every time we get new data what the situation is. But then our operators look at the data and decide which close approaches are more threatening, and then we will do more manual analysis on that. And then also there's human in the loop as we work with the owner-operator of the spacecraft to decide what mitigation option may be available to them or what they might want to exercise. So different owner-operators have automated different portions of their maneuver planning process, but there's usually a human in the loop there to make decisions. We have noticed working with some constellations as they're coming up, you know, there's certainly much more of a need these days for automation on board, because when you have that many spacecraft, it's hard to process things on the ground. We've noticed that not everyone is sending their ephemeris data out to the 18th for screening before they execute the maneuver. They're just sort of planning it on board and executing, which means other operators can't know where they are or where they're going, and there may end up being a maneuver on maneuver type collision. So there's definitely a need across the industry for figuring out how we can provide automation that still builds in time to communicate with other operators, because that seems to be key, or finding a way to automate that communication so that we don't have this space safety threat.
Okay, good luck, Anna. And I'm sure that's a situation that never stays still, with more operators coming online, different technology and different. I mean, okay, so good luck to you, and thank you again for joining us. And hopefully we get a few more questions and a bit more time to come back to you again. But I'm going to keep moving on, if you don't mind, and head back to our colleague from Chile, Ms. Para Rojas. So, Ms. Para Rojas, if you wouldn't mind just telling us a little bit more. You raised two really interesting points, both on registration and just how that process has come forward from a Chilean perspective in terms of registration of objects, and hopefully where that's going forward in terms of why you think that registration is so important. So that's obviously guideline A5 and a few other parts of that section. And then also those final points where you mentioned the public value and then also the economic value of what you're trying to do in Chile. So two points there. Please do take them as over to you.
Thank you. Well, about the registration, well, we have think that is a very key issue in the project development, because obviously there are so many efforts maybe located for different institutions, and we need a way to consolidate this information in order to be available for all people, and in order maybe to not duplicate efforts, and to be available to this information for everyone. Then about the all this information will be, as I said, available for different productive sectors. So we hope, obviously, to use the exploitation, not only the data, but also the processing and the technology involved in this project to be used by the academic purpose, research, and also for processing oriented to maybe agriculture, maybe minery, maybe space weather. That are one of the topics that we are identified to be used, the data to be collected. And as I said before, not only with the satellites we are included in this project, but also with the information that we have currently available without other sensors. So it's a very important step for us in order to consolidate this capability, and considering that this will be a tool also for several development sectors.
Absolutely, and you're doing a great job. I mean, FIDAI is a fantastic event that you host regularly in Chile, and we're always very happy to contribute here from the event and to those activities as well. So, all the best to you, and good luck on these very important endeavors. And thank you again for joining us today and for sharing us your remarks. I just remind everybody that Ms. Para Rojas' comments and presentation, as with all the other speakers, will be available online afterwards, and do feel free to reach out, not just during this event alone, but going forward if you want to take forward any of these conversations with our speakers. So thank you. Now I'm going to jump back to you, Jacob, if you don't mind, just with a few more questions. I mean, I was fascinated. Obviously, we often talk about congestion and competition and the contested nature of space, but you're highlighting on the ESA Space Safety program raises so many other C's, such as codependency, co-investment, and soon to be cohabitation. So it really does give that message that we kind of stand and fall together on this issue. So I very much appreciate the focus so much on your remarks there. Now, in terms of kind of follow-up questions, it's really looking towards those B guidelines that you were talking about. So this is the process of improving the accuracy in how you gather and then communicate the data that you're talking about. And then also just a little bit more, if you wouldn't mind, about how that connects into the scientific and the academic community, which is another key part of the guidelines in section D. So please, back to you. The floor is yours.
Thank you, Ian. And I think similarly to the speaker from NASA, Laurie, it's good to refer to the steps that are automated in our conjunction assessment methodology, and then the steps where there is a man or woman in the loop. So to improve accuracy, I think there are steps we have taken at the automated level. So when we screen, for example, the CDN messages coming in, that is for us an automated step. And we can do some things there in that automation to make sure that we understand the various different warnings, to make sure that we're pulling out the key information to support accuracy. But then it goes into the more man-in-the-loop step. So once an event has been selected as potentially being a high-interest event, and we have a certain threshold for that, or a critical event where it is an even higher probability of collision or proximity, then you start having the analysts involved to look at that and put it through a set process. And there, to improve accuracy, they might be using different algorithms or software tools, either things you could buy commercially or things we have developed nationally, to understand the warning available to them. But the most important step that they can take at that phase is then to task a sensor, to ask a radar or a telescope to examine the orbit of an object, particularly if there is a collision between a piece of space debris and a UK satellite. For the piece of space debris, there will not be a ephemeris file, there will not be a known position or orbital track, and so we need to either task a sensor or somehow try and gain a better sense of where that piece of space debris is and what its particular orbit might do in future, so to propagate the orbit forward. And that is possible to do. You can refine that slightly with calculations and software, but really you need to track it with an independent sensor. And that is, I think, where the collaboration is most crucial. Either collaboration between nations, so we might share sensors and share information, and if my sensor can view the piece of debris you are interested in, then maybe I can give you the data from that, and next time you help me. There's one relationship. But also collaboration between industry and government. So there are companies that will operate a network of telescopes, for example, to observe the geo belt. Those are opportunities for government to say, well, I don't need to buy a radar or a telescope. I will pay a company to deliver this service for me and provide that data. And for the UK, where a lot of our focus is on supporting our commercial UK industry as well as protecting our own national interests, and that collaboration between industry and government is crucial to improving the accuracy of our conjunctions by using sensor data, but also making sure that we get the best possible coverage of various different orbital regimes. I will touch on your next question next, and I don't know if Laurie, you want to come into that on the how we work with commercial data in a second as well. I'll leave it up to Ian.
Thanks, Jacob. I'll just invite Laurie to see if she does want to come in on that point before we move to the second part of the question.
So right now, NASA is investigating use of commercial data with our systems. We do get all of our data, as I said before, right now from DoD. So we've been working with them on a method to bring in the commercial data and mix it together at the observation level in one place so that we can have one solution and not be the man with two watches. So we're looking forward to continuing testing that and being able to take advantage of more of the data sources that are available.
Great stuff. Great stuff. Okay, Jacob, back to you.
Okay, thank you, and thank you, Laurie. Sorry for putting you on the spot. It's good to understand how other nations do it too. So on your question about how we then reach out to the academic or research community, so that for us there are maybe two different ways of doing that. Firstly, we seek to use the academic community, and I think there is a network called Gnosis, which has been mentioned in the chat of this meeting by a colleague of mine, Catherine Courtney, to bring in the ideas for how we can better do sensor data, so sensing in particularly, but also some of the data processing steps for conjunction assessment. And that might be, for example, using satellite laser ranging to better understand where particularly small pieces of debris are, or it might be other techniques too. So we pull on the academic interest in this community to bring in new types of capability. We also then help to collaborate by providing them some outputs from what we do as well. So this might be the availability of data from our academic sensors. So we share that with several different bodies, and we can share that with UK academics as well, because it comes from a scientific sensor, so we will share it with scientific users. And also then helping to warn different institutions, so universities that might operate satellites, or other groups that aren't companies or governments. We will also inform them about orbital conjunctions that we see to help them protect themselves from space debris or other risks in space. So we're both giving out some data related to our work, but also using our conjunctions to protect our academics and our researchers' ability to access space at all. Thank you, Ian.
Hey, perfect. And as I've said quite a few times today already, thank you for that example, and just all the best to enhancing and expanding those great activities that you just covered off there. I'm sure it's appreciated by everybody involved. Okay, I'm going to head back to Val now, our fourth speaker, but just before I do, I just wanted to pick up a question which, after Val's spoken, I'll then put back to all four speakers who want to come in. And that's really a question on the civilian and the non-civilian use of space. And really from a space sustainability perspective, just hearing from our speakers today, if they think that there is a distinction between what would be important for the civilian, what would be important for the non-civilian use of space from a space sustainability point of view. Is there a distinction? Is it just the same issue for both sides of that particular coin? Any comments from all four would be more than welcome. But as I say, first I'm going to go back to you, Val, please. So you focused on B7 space weather, such an important topic. Thank you so much for breaking that down for us. And as I say, I'd just like to pick up a few points on, you mentioned common formatting, so crucial and something very dear to us here at the UN's heart, you know, having a very universal perspective in trying to increase cooperation across different operators, different countries. I'd love to hear a little bit more about the process of how you put that into place in South Africa. And then secondly, you know, that relationship with satellite operators, that relationship with the operators, and how you get the information that they need to keep their objects safe, and just how that looks like in practice and where that might be going in the future, considering we're going to have a lot more operators, not just in South Africa and across the African continent, but globally. So please, just a few points from you on that side. Thank you.
No, thanks, Ian. Just on the common formatting, so we can draw lessons from other domains in the space value chain. So for example, on the Earth observation side, South Africa, together with the European Commission, US, and I think it was China, was quite instrumental in setting up the group on Earth observation. And so this is the system of systems, Earth observation system of systems that are globally sort of decentralized, you know, located all over the world. And there was a number of key issues that we were tackling in that framework of systems of systems. One is interoperability of systems, and that came back to the data architecture in terms of common data formats. And I think we've learned a lot from that experience in terms of how do we draw down from what's happening internationally, and how do we actually put stuff that we've learned from our side. The second element, which is what's actually happening here in South Africa, So we one of the co-hosts of the Square Kilometer Array, which is a mega radio astronomy. It's actually a big data problem. So we, in terms of when the SKA comes on board, we're looking at about 10 to 100 times the global internet traffic. And a lot of the technologies that's required for that instrument is pre-competitive. It doesn't exist at the moment. But we've seen a number of developments happening over the years. And so what we've done is we've partnered with our astronomy colleagues here in South Africa and started to build on the Earth observation side data cube platforms in terms of pre-processing data that goes back to the 1970s when the Landsats first came on, as an example. And so we're starting to do that. And now this is called Digital Earth South Africa, but there's also an initiative called Digital Earth Africa, which is about plugging the 55 different African countries from an Earth observation point of view. And again, you need common formatting across the continent. And we're working together with even the European colleagues in terms of the Copernicus or the Sentinel missions and seeing how all of this falls in together. So we're bringing that experience as well into some of the other domains like the LTS and how we pull that through in terms of new learnings. And a big part of the radio astronomy is this issue of serendipity. You don't know what you don't know, machine learning, artificial intelligence. How do we bring those new elements that we're not used to working on into this domain as well? And then the relationship with the satellite operators, I think because of our geographic positioning, we work with a number of other satellite operators. So we also host equipment for other operators from Europe, Asia, and so on. So there's a very strong relationship between South Africa and other satellite operators around the world. And if you look at your geodetic reference frames that you require to map all of the, the space debris and stuff like that. If you look at our site at Hartbeespoort, the Radio Astronomy Telescope, it's a key part of what is called the VLBI network, the Very Large Baseline Interferometry. You take out the South African station and you've got a gap in southern hemisphere. Okay, and that's very important because if you want to map the geodetic reference frame down to centimeter levels, you need this kind of ground infrastructure. And so again, when you start to reverse that in terms of how do you use that for the LTS as well, that becomes very important. So yeah, I think for us as well, I should mention this is especially on the LTS now that it's coming through, it's also trying to see what the opportunity spaces are. And I think the international collaboration in terms of having these kinds of discourses is going to be quite critical in terms of finding each other and looking at new innovative ways of working. Thanks.
Absolutely. No, thank you. And thanks for the vote of confidence at the end there for the work we're doing here in Vienna. Appreciate that. We're trying our best, and hopefully it's meeting the challenge. So thank you again for that, sir. Okay, great. So I'm now going to just give all four speakers a chance to come in, and I'll just ask you to just turn on your camera if as a way to indicate that you would like to take the floor. And it really is just that final question. And of course, it's a little bit of a zinger perhaps, but it's really just kind of looking at both the civilian, as I say, non-civilian side of the coin in terms of space operations. And when you apply that space sustainability lens in terms of what's important, from an implementation point of view for the guidelines, is there any useful distinctions that we can make in simple terms, or is it just a really a one size fits all issue? So I'm going to stop there and just see if anybody does want to come in with any remarks on that particular point. Any takers? Okay, Jacob, please, back to you.
Thanks, Ian. I think it's a question of actually where the strength of collaboration lies between military and civil partners. Military activities in space is something we have to work with. There will always be a national security angle to space, and actually it's the extent with which civil agencies like mine and others can work closely with our military colleagues to make sure that we can successfully monitor space, that we can successfully understand collisions or space weather or threats or hazards. It's all about the role the military can play in helping us achieve space sustainability by perhaps sharing capabilities, radars or telescopes or analysts, whatever it may be, to support our activity to look at it from a more sustainable perspective. So I don't necessarily see it as a risk. So something the military does is different than what we do. I see it as an opportunity to work together and share what it is we do on the military and civil angle.
Great. And an opportunity, hopefully we can all take advantage from. Val, please, back to you.
Ian, I'm just going to put one slide up so that because it's something that happened last week in South Africa, but it's kind of answering your question in a way. You know, if you follow the history of South Africa, we had a very huge military program in the 1980s. And we had a launch vehicle, we had nuclear weapons at that time, and there was a big international pressure to denuclearize and looking at the non-proliferation regime. And round about when we won our democracy from the apartheid regime, there was an act put in place called the Space Affairs Act, which is still relevant. But the primary tenet of that act was around the control of dual-use technology, more from a military perspective, the missile technology control regimes and so on. But what we've seen as things sort of shut down, that there was actually for the socio-economic development of the benefits of that. And then you saw this policy landscape started changing, and around about 2008, we saw the national space policy coming through. And that gave birth to the civilian space program, the space agency. And in fact, last week, around about 2021, right where we are now, we're now introducing a new bill. So we're going to repeal that act and come up with a new, well, the bill is ready. And so we got the green light to do the final approval, which will see the act replaced by, so we've seen this transition from the military to the civilian. And I think at the moment, the civilian space program is kind of getting dominance in South Africa. A lot of the competency is around that. And a big part of the regulatory bill is now that we're having this growth spike or spurt in South Africa, there's going to be a lot of new industry players. And how do you regulate the industry player when the state is liable for any accident in space, when you have private sector players now playing in that space? And I think that's why the regulatory bill is becoming so important, that we limit that liability. I thought I should just share that with you. Thanks.
No problem. And that's the point where I'm very thankful that I'm an international civil servant rather than a national civil servant, because that's, you know, that's no easy fix. But good luck to you there. Absolutely. Okay, I mean, on that question, I mean, we are over time now, but it's been such a great discussion. I'm sure everybody would be more than happy to continue going, but I will just see if our other two speakers want to come in on that particular point. Okay, great. Okay, well, oh, yep, Laurie, please, over to you.
Sorry. So I just wanted to expand on what Val was saying. You know, we have the civil and military side, but we also now have a large commercial component. And, you know, the national actors have been kind of working in this area for a number of years. With a lot of the commercial entities, it's kind of new, and there's not a really good centralized place where they can learn about space safety, but the space safety concerns really affect everyone equally. So being able to reach out and bring them on board and you know, share with them, I think will be really important as we go forward, because they have their own business case and their own ways to use space. So it's a different model.
Absolutely, absolutely, and a model, as I say, that's getting increasingly more complex. So there's no time to lose. Okay, I'm just going to see if anyone else wants to come in on that point. Okay, perfect. Well, I'm going to call it time there on the session. I would just, before I hand back to my colleague Annie, I'll just like to give a personal thanks to all of our four speakers, and also for the questions, great questions coming in. Really appreciate you sharing your time with us here today. It's been an absolute pleasure to be a moderator. And from me, thank you to everyone for joining us. Okay, Annie, please, the floor is yours. Back to you. Thanks.
Thank you, Ian, and indeed, thank you so much for these very wonderful presentations. this afternoon and also in the morning. So I would just like to remind everybody that in case you couldn't make it in the morning, we will make the recordings available shortly on our website at unusa.org, and you will be able to see the videos even or replay them in case you already saw them this afternoon. I would also like to acknowledge that this event and activities of this project would not be possible without the generous support of the UK Space Agency. So we really appreciate the contribution. And I would also like to remind everybody that my colleague Tanya just posted a short feedback form that we would really appreciate if you could have 1 minute to fill it out, as it would help us looking ahead for our third event. And that being said, March 15 is the date of our next promising event in this series, where we will cover regulators and space policymakers. We will use the same format, morning and afternoon panel sessions and Q&A after each session. And we will post the registration details on this third event shortly on our website and social media channels, so please stay tuned. That being said, thanks again for the presentations, for the speakers, and also for all the listeners. Thank you again, and we wish you a good day. Thank you. Goodbye.